A parallel plate capacitor consists of two conducting plates, each with area A, separated by a distance d. One plate carries a positive charge Q, while the other carries an equal and opposite negative charge. To begin our derivation, we define the surface charge density, sigma. This is calculated by dividing the total charge Q by the surface area A of the plate. Between the plates, an electric field E is established. According to Gauss's law, for two closely spaced plates, the electric field strength is equal to the surface charge density divided by the permittivity of free space. By substituting our previous definition of sigma into the electric field equation, we find that the field strength is directly proportional to the charge and inversely proportional to the area and permittivity. The potential difference, or voltage V, between the plates is the work required to move a charge across the distance d. It is calculated by multiplying the electric field E by the separation distance d. Now, we substitute our expression for the electric field into the voltage formula. This gives us the potential difference in terms of charge, distance, area, and permittivity. Capacitance, denoted by the letter C, is defined as the ratio of the magnitude of charge on one plate to the potential difference between them. To find the capacitance of our parallel plate system, we divide the charge Q by our derived expression for voltage. Notice that the charge Q cancels out from the equation entirely. The final derivation yields the formula C equals epsilon naught times area divided by distance. This shows that capacitance depends only on the physical geometry of the capacitor. Graphically, we see that increasing the plate area increases the storage capacity, while increasing the distance between the plates weakens the field's influence, thereby decreasing the capacitance. If a dielectric material is placed between the plates, the capacitance is multiplied by the dielectric constant kappa, further increasing the device's ability to store energy. In summary, by relating the electric field to the physical dimensions of the plates, we derived that capacitance is determined by area and separation. This concludes our lesson. Generated by Vision Solve AI.